Right, we have the integral of the secant of x with respect to x, and we want to perform and evaluate this particular integral, and we present a solution to this integral, but we shall present three independent solutions to this integral as follows. Right, so now we note that we've been given the integral of the secant of x with respect to x, like so. And what we then do is to consider the integral of the secant of x. And we proceed to multiply these by the secant of x plus the tangent of x, right, divided by the secant of x plus the tangent of x with respect to x. And now multiplying the top, the secant of x times the secant of x, the secant squared, and the secant times the tangent is the secant tangent. So this then equals the secant squared of x plus the secant of x tangent of x. You divide by the secant of x plus the tangent of x dx. Right. And at this point, we let, right, so we let u be equal to the secant of x plus the tangent of x. And we evaluate du dx. And the derivative of the secant is the secant of x, the tangent of x, and the derivative of the tangent of x is the secant squared of x. And at this point, we proceed to manipulate this. But in manipulating this, we want to make out of these dx the subject of the equation. So in other words, we have du dx, right, which is equal to the secant times the tangent, secant of x, the tangent of x, plus the secant squared of x. And what is then dx? Right, so dx is du divided by, right, the secant of x, the tangent of x, plus the secant squared of x. Right, so we have that dx equals this. And at this point, we proceed to take this particular step and carry it forward. So we shall take this step and take it forward. So we have the integral, right, of the secant squared of x plus the secant of x, the tangent of x. And you divide these by the secant of x, the tangent of x, dx. At this point, we perform substitution. And what is then the secant of x plus the tangent? It is only u. And in the numerator, we have the secant of x, the secant squared of x, plus the secant of x, the tangent of x. And we multiply these by dx. What is dx? It is du over the secant tangent plus the secant squared. Right, so it is du over the secant of x, and we can write this the other way around. We can write the secant squared of x first. Right, so writing the secant squared of x plus the secant of x and times the tangent of x, like so. Okay, and upon careful examination, we're able to see that these cancels that, leaving us with only what? So this leaves us with the integral of 1 over u du. Okay, 1 over u du. And what do we then do at this point? You have the integral of 1 over u du. And what is this integral here? It is the natural log of the modulus of u plus c. What is the u here? What is u equal to? Right, we recall that u is the secant of x plus the tangent of x plus the arbitrary constant c of integration. And at this point, we're able to conclude and say the following. Hence, right, hence the integral of the secant of x dx, this integral equals the natural log of the secant of x plus the tangent of x plus the arbitrary constant of integration c. All right, and we have this exactly. Right, so we continue right now to explore our second method. Let's explore. So in other words, we can most certainly say with confidence that the method we used here was just method 1. And we shall proceed to use method 2. Right, so using the second method, we have the integral of the secant of x with respect to x. And now this here is actually method 2. Right, so in using method 2, we recognize, first things first, that the secant is 1 over the cosine of x dx. And we proceed to then say to 1 over the cosine of x. We multiply by cosine x over cosine x with respect to x. Right, and what is the meaning of these at this point? Well, the meaning of this is that we shall have a square in the denominator. So in other words, this can be written as the integral of cosine x divided by cosine squared of x with respect to x. And we take this forward and write the following. So this is equal to cosine x divided by cosine squared of x dx. And what is cosine squared of x? Cosine squared of x is 1 minus sine squared of x. At this point, we perform substitution and we proceed to let u be equal to the sine of x. And this means that du equals the derivative of the sine is cosine x dx. And then this means that dx is du divided by cosine x, like so. And we then proceed to carry this forward and then say we have the integral of cosine x divided by 1 minus. Right, so we know very well that it is 1 minus sine squared. All right, with respect to x. And then this is the same as cosine x, right? The sine is u, so in the place of sine, we put u. And what is dx? Is du over cosine x. It is du over cosine x. And what then do we get out of this? So those two cancel out. And what we're then getting is we have 1 over 1 minus u squared du, like so. And then what do we have at this point? Right, so this is equal to 1 over the 1 minus u squared. This one, 1 minus u squared, can be factorized. And you can write it as 1 minus u, 1 plus u du. Right, and we proceed to use something we call partial fraction decomposition. Right, so partial fraction decomposition. And that would then mean that 1 minus u into 1 plus u, which is a over 1 minus u plus b divided by 1 plus u. And at this point, if we simplify these, it becomes 1 equals a open bracket 1 plus u plus b open bracket 1 minus u, like so. And if we have that 1 is a open bracket 1 plus u, okay, that's what we write down, plus b open bracket 1 minus u. And this means that you have a plus au plus b minus bu. And then this is a minus b u plus a plus b, like this. And this implies that a plus b, the constant, is 1. And a minus b, the coefficient of u, is 0. If we add these two equations, a plus a here gives us twice a, and the b minus b is 0. And if we add 1 and 0, we get a 1. And upon solving and making a the subject of the equation here, we have that a equals 1/2. But this equation, this bottom equation, that says a minus b equals 0, also this equation means that a equals b, but we know that a is 1/2, so that b is also 1/2. And this means thus, if you have 1 over 1 minus u squared, right, we have a over 1 minus u plus b divided by 1 plus u. And if we have 1 minus u squared, we have already seen that a is 1/2, but also we have seen that b is 1/2. And this is what we are able to get at this point. And with these, then, we are in a position to continue. And these can also be written as 1 minus u squared, which is 1/2, right, times 1 over 1 minus u plus 1/2, open bracket, 1 over 1 plus u, and that's what we have. So now, hence, we have the integral, right, of 1 over. Right, so if you have the integral of 1 over 1 minus u squared du, 1 minus u squared du, and we know very well that this is the integral of what? 1/2. Right, 1 minus u squared is 1/2, open bracket, 1 minus, or 1 over 1 minus u. 1 over 1 minus u plus 1/2, 1 over 1 plus u, like this, du. Okay, so that is what we have exactly. That is what we have precisely. And so what is the meaning of all this here? What is the meaning of all these? So at this point, we can be able to perform integration, but now something very trivial is the following. So we can write here 1/2 minus 1/2 times the integral of minus 1 over 1 minus u du, which is -1/2 times the integral of -1 over 1 minus u. Okay, so this is exactly the same as that part, but now further distribution of this integral here, we are able to have 1/2 times 1 over 1 plus u du. And this is very correct. Now the derivative of the bottom is -1. The derivative of u plus 1 is just 1. And in mathematics, if the derivative of the denominator is the numerator, then the integral is the natural log, meaning we have the following. We have -1/2 times the natural log of 1 minus u plus 1/2 times the natural log of 1 plus u plus c. And so what is all this here? At this point, it is very, very clear that we can take out the coefficient 1/2, obtaining 1 plus u minus the natural log of 1 minus u plus c. And this is 1/2, the natural log of 1 plus u divided by 1 minus u plus c, like this. Now, at this point, it is very, very clear that we have the following, and we need to recall, right? What do we recall? We recall that, first, let's write this step for us to even recall further. So this is the natural log of what? Okay, this step is 1 plus u divided by 1 minus u plus the arbitrary constant c of integration, and this is 1/2, which is 1 plus, what is the u? It is exactly sine x divided by 1 minus sine x plus c, the arbitrary constant of integration. So we remember that u is the sine of x. There are a couple of things that remain very important. So we're able to say thus. Right, thus you have that the integral of the secant of x with respect to x. We've already seen, therefore, that this particular integral here equals 1/2 times the natural log of 1 plus the sine of x divided by 1 minus the sine of x plus c. So we concluded this result here, and we have seen that the integral of the secant of x can be written like this. Okay, this allows us to make the following conclusion and to make the following celebration. Right, so we can celebrate and say hence. Right, and say hence. Whenever one has the integral of the secant of x with respect to x, we have already seen that it is the natural log of the secant of x plus the tangent of x plus c, but also this integral of the secant of x is the natural log of 1 plus the sine of x divided by 1 minus the sine of x plus the arbitrary constant of integration c. Okay, we've been able to establish these two results here as the integrals of the secant of x, but we have much more to show. And now we actually proceed to show another method. In other words, this method we used here was method 2 to show this particular answer that involves partial fraction decomposition. And then now we proceed to show another method as well. What is the next method? Right, so we continue with our investigation and celebration. of known results of the integral of the secant of x. And here, this one is method 3. Right, in method 3, we take note of the fact that this integral of the secant can be found in many, many ways. In other words, this is exactly the same as 1 over the cosine of x dx. Okay, that is what we have. And at this point, we use substitution. So we actually let t be the tangent of 1/2 x, 1/2 x, like so. And so if this is the case, we shall then be in a position to use these particular results as follows. For example, if you have the sine of x, the sine of x can be written as the sine of 2 times x over 2, which is 2. The sine of x over 2 times the cosine of x over 2 using half-angle formulae in trigonometry. Okay, now this is much celebrated because we have seen that the sine of x is twice the sine of x over 2 cosine x over 2. Whereas simultaneously, we note that we can be able to draw this particular triangle that is the angle x over 2 for the suggested substitution. And the suggested substitution uses what we call our t substitution, where t equals the tangent, right? The tangent of 1/2 x. So that now if you have the tangent of x over 2, it is actually the opposite over the adjacent. Right, so if it is the opposite over the adjacent, we proceed as follows. Right, let us just clean this up. We clean this up. So yeah, that's what we have. So at this point, we have that this is the opposite over the adjacent. So that at this point, we have that this is 1 plus t squared. Okay, so this triangle is right angled here, and this is the angle that we have x over 2 here. Okay, now what is all this and what conclusions can we draw out of this? Well, it means therefore that if we have the sine of x, right, it is actually then equal to 2 into what is the sine? It is opposite of hypotenuse. T over the square root of 1 plus t squared. And what is the cosine? It is adjacent over hypotenuse, which is 1 plus t squared. And therefore, this is the same as twice t divided by 1 plus t squared. Okay, so yeah, just take note of that as something that is very important. So it's t squared here. And then now we also are able to write and have the following result for the cosine. Okay, this is what the sine is, but we can be able to find the cosine as well. So the cosine of x is the same as what? Right, the cosine of x can be seen in many ways. So it is first and foremost double x over 2, like this, okay? And it is exactly the same as cosine squared of x over 2 minus the sine squared of x over 2, which means cosine x is what? What is the cosine here of x over 2? It's adjacent of hypotenuse, which is 1 over the square root squared minus this is the sine is opposite of hypotenuse, which is t over the square root of 1 plus t squared. We square this, okay, which is 1 minus t squared. divided by 1 plus t squared, like this. So this is the cosine of x. Okay. But now this is something that remains very, very important for us. But the tangent of x. The tangent of x, we know that is the sine of x over the cosine x. So we've already seen the sine of x. What is the sine of x? It is 2t over 1 plus t squared. 2t over 1 plus t squared. Now the cosine of x is this, but it's in the denominator, so we invert to this. And this cancels out, giving us 2t divided by 1 minus t squared. So we have that the tangent is 2t over 1 minus t squared. So that the tangent of x is 2t divided by 1 minus t squared. So that in the end, we are able to write the following. But simultaneously, without using much direction, the secant of x plus the tangent of x. What is the secant of x plus the tangent of x? The secant is the reciprocal of this, which is 1 plus t squared over 1 minus t squared. 1 plus t squared over 1 minus t squared plus the tangent, which is 2t divided by 1 minus t squared. Right, adding the top and bottom, we're able to see that, let's write at the bottom everything, so that we have that this is the secant of x, the tangent of x, which is the tangent of t squared plus 2t plus 1 divided by 1 minus t squared. And this is 1 plus t all squared divided by 1 minus t squared. And this is the same as 1 plus t all squared divided by 1 minus t into 1 plus t. And now you cancel this out. So in other words, you're going to cancel out 1 plus t with 1 factor, leaving us with 1 there, so that in the numerator of this, we have 1 plus t. Okay, so we're going to have here 1 plus t. Let's just write that one down. So we have 1 plus t divided by 1 minus t. Right. In other words, we make the observation that the secant of x plus the tangent of x can be written in terms of t, and it is 1 plus t over, it is 1 plus t over 1 minus t, like this. But then what do we do with all these things here? What then do we do with all these things? Okay, so we proceed to analyze this, but very, very carefully as follows. Right, so we're going to just clean this up just now. Right, we're going to clean this up very, very quickly. Okay, right, so we are able to make the following writing and the following inferences. Okay, so now we have this integral here. And we perform and use the rest of the substitutions that we have. Okay, that we have already. So, for example, now we know that the integral of the secant of x with respect to x is the integral of 1 over cosine x with respect to x. And so what is this here? This can be written as the integral of 1 over, what is cosine x? Right, so cosine x in terms of t, we've already seen that is 1 minus t squared over 1 plus t squared. We just got that one. And what is dx right now in terms of t? To find that one, let me just check if we established that one. Okay, so we did not. But now recall that t equals the tangent of half x, so that we come here and we use it. Right. So we're going to write here, for example, t is by the suggested substitution 1/2 x, so that dt is 1/2 the secant squared of 1/2 x dx. Okay, that's what we have here. So what is dx now? It is dt over this. It is dt over this part. And now if we actually are able to use that, but also the couple of things that are very important for us to consider. So what is dx? Right, so dx is dt divided by, so you have 2, which is the secant squared of 1/2 x, which is 2 divided by, the secant is 1 plus the tangent squared of 1/2 x, like this. And you have the dt, which is equal to 2 dt divided by 1 plus, now the tangent is t squared. The tangent of x of, the tangent squared of half x is just the same as t squared here. Okay, so in other words, wherever there is dx, we put twice dt over 1 plus t squared. We put twice dt over 1 plus t squared. Okay, so perform further multiplication, which is twice dt divided by, okay, so we have 1 minus t squared. Right, giving us the integral of the secant of x dx, which is equal to, right, twice dt divided by what? 1 minus t squared. So what is the meaning of all these here? So we have dt here. Now we have this exactly. We have this exactly, but we remember from the partial fraction decomposition that we got that if we have 1 minus t squared, we did it, but it was in terms of u a previous steps back, so that this is the same as 1/2 1 over 1 minus t plus 1/2 open bracket 1 plus t, like this, dt. Right now, multiplying through by the 2, which is the integral of 1 minus t plus 1 over 1 plus t dt. Right, so obtaining the integral of the secant of x dx, okay, which is exactly this here, which is 1 minus t dt 1 plus t dt. And now this is very, very interesting for us to consider, and there are a couple of things that we need to consider. But now this is straightforward, because you can introduce a minus and put minus 1 over 1 minus t dt plus the integral of 1 plus t dt. Okay, so the derivative of this is minus 1. Right, so if that happens, it becomes minus the natural log of 1 minus t plus the natural log of 1 plus t plus c. And this is the natural log of 1 plus t divided by 1 minus t plus c. In other words, we're able to see that, right, thus it follows, therefore, that the integral of the secant of x with respect to x equals the natural log of 1 plus t divided by 1 minus t, like this, plus the arbitrary constant of integration c, so that the integral of the secant of x, right, the integral of the secant of x is the natural log of the following. Okay, but now what is the 1 plus t? We remember there's something I wrote here. There's something I wrote. Right, so in other words, the secant of x plus the tangent of x is 1 plus t over 1 minus t. So let's check here. So now if you have 1 plus t over 1 minus t is exactly the secant of x plus the tangent of x plus c. Okay, what have we been able to, but obviously not only this, anyway, not only this, because somebody can say, okay, but I can see that the integral of the secant of x dx is the natural log of the following, from the fact that the t is the tangent of 1/2 x divided by 1 minus the tangent of 1/2 x, and we add the arbitrary constant c of integration. It allows us to make the following deductions, and we're able to say hence. All right, we're able to say hence the integral of the secant of x with respect to x is first the natural log of the secant of x, right, plus the tangent of x plus c. And we also have the integral of the secant of x with respect to x. And we've already seen that this particular integral is very much celebrated, but it can be written as the natural log of what? Of 1 plus the sine of x divided by 1 minus the sine of x plus c, and which is the integral of the secant of x. This is the natural log of 1 minus. Okay, see what we got here. We got 1 plus the tangent of 1/2 divided by 1 minus. Okay, so we have 1 plus the tangent of x over 2, or let's write it as 1/2. Okay, so 1 plus the tangent of 1/2 x, like this, divided by 1 minus the tangent of 1/2 x, like this, and we add the arbitrary constant of integration c. So in other words, we have been able to establish a series of results that are celebrated in calculus. What are the results? Let us sum them up. So in other words, we know that the integral of the secant is this. In other words, the integral of the secant of x with respect to x is the natural log of the secant of x plus the tangent of x within the modular sign plus c. But also we know that, and we have seen that before, that the integral of the secant of x is the natural log of 1 plus the sine of x divided by 1 minus the sine of x within the modular sign plus c. The integral of the secant of x with respect to x, the natural log of 1 plus the tangent of 1/2 x divided by 1 minus the tangent of 1/2 x plus the arbitrary constant of integration c. And we celebrate these particular 3 results here. And now these are the results that we need the most. And these are the integrals. These 3 are the integrals of the secant of x with respect to x. Thanks everybody for watching, and goodbye to you.